Welcome, everybody. Thank you for joining this session, or like the gentleman in the front row, just staying with us here in the yellow room, because this is the best room, to be honest. We have our top voted session now here on the agenda for you, and this one's called CAP Best versus Bad Practices. And of course, who else could be giving such a session other than the founder and the chief architect of CAP, who I would like to welcome on stage, our very own Daniel.
Thanks. Yeah, so thanks for showing up here. Put some pressure on me because I didn't prepare anything until 10. But now I have something. Yeah, but no, serious. Let's maybe do it interactive session as much as possible. So feel free to raise your hand, and then you might get a microphone. Otherwise, yeah, it's about CAP best and bad practices. Back to that. You heard me maybe talking a lot about this topic of best and bad practices, and you saw the pages and CAP hire showing up about best and bad practices. So why was that? Because we figured out that even though we have the greatest documentation ever, people seem to not get the point or missed some points and did some mistakes. So didn't follow the best practices, maybe even didn't know about the best practices, which is a bad practice on our side. Obviously, our documentation is not good enough. And so at the end of the day, this brought us to, yes, we have to talk more about best and bad practices. And we have to do what was our best practice in the very beginning of CAP. These two major saying I mentioned, good enough is not good enough, and the other one is no ivory towers, always go the reality check. So check with our adopters, projects built on CAP, how they actually use it. Do they understand it? Did they get it? Or did they do a lot of mistake? And if so, let's fix the root causes for them doing mistakes. So see that session as part of that initiative to trying to talk about bad practices and thereby to find out ourselves how we can avoid or help you and everybody else avoiding the bad practices and get you to the best ones. I found that picture quite fitting. That's from my favorite book, as some of you might know, of my youth when I did Smalltalk development. And it started with that graph here saying, or telling the story, Smalltalk is different. At that point, people knew Pascal and C and what have you. Object orientation was very strange, very alien. And there came Smalltalk, even with a different syntax. And what that guy was saying, the author of that book, is, yeah, it might look strange, so you are confronted with some level of discomfort in the beginning to what you knew or used or did so far, but it's worth climbing that hill because very soon you get a productivity gain and boost. And would be great if CAP is similar. At least the discomfort thing might be true, like showcased on these CAP not equals the right-hand side kind of strings. That is another painting that I did to educate where CAP came from and to argue that CAP is much about best practices. Yeah, so here's CAP, here's Khaleesi. It's like CAP style. And this CDS, and as you might know, CDS was my first strike, first whatever. It was CAP version 1, started in 2012. And this, in turn, came out of this Kronos project, which was the code name of a firefighting project where we analyzed the root causes of bad performance in an unnamed product of SAP. Yeah, the sorting could be better. No, back here. We really analyzed the root causes of these problems. It was very business object centric, ORM centric. It was an overly stateful model, so not really scalable. It was very fragmented logic, and very fragmented logic means you call a lot of methods, and in that case, implemented in ABAP, each method call is 3 milliseconds. It's not really fast, right? So, yeah, things like that. The key design principle to fast forward through this slide, what you see to the right-hand side down, is capture intent to automate things instead of doing programmatic, fragmented stuff. Service and event-centric paradigm, querying, push down to DB. We will see this exactly here. Okay, now I did the fast forward now here. And that is basically repeating what you can see in the getting started best practices thing, which is basically the key concepts and core concepts. Thanks a lot. Lunch was not good. Yeah, so it starts with domain modeling, aspect-oriented modeling. I walk through and then I give some examples. The services thing, and services are stateless. Events are everywhere. Everything is an event at runtime. Querying is key, and this push-down thing, maybe stopping here. Quite a lot of frameworks and approaches work like that. You have a database, you have a layer in between, and you try to marginalize your database. You read data, keep it in a cache, and then try to serve the data from the cache. Problem is you have to read a lot of data in maybe inefficient ways, while databases are very good in reading data and also giving you very denormalized data in their query capabilities. So the idea that we found at that time, and that showed up in ABAP with CDS and SADL, so they have the same outcome applied to the ABAP world. Push down to DB is key, and therefore querying is key. GraphQL and OData follow the same idea and principle. Instead of reading full objects to display 2 columns out of these objects, just get the information from the client, what you want to see on the client in a query, GraphQL query, translate it on the way to the database and get exactly that data back. So GraphQL, OData, CAP are very similar on that. Now, a second level of best practices. This is like out of these core concepts, you get these additional things, and then comes a bad practices thing. Sometimes it feels like you are this poor guy with a car, and the other guys say you are the job killer, or they're just too busy, as Muhammad Alam, our manager, responded to me with that cartoon here. Yeah. And they continue sort of, ignore this internal for now, that's just an artifact, with this kind of list. And yeah, OData $batch is here, by the way. And I just was reminded in the meeting before that I wanted to add some more. Ah. Okay, now let's go in some examples, some details. Yeah, domain modeling. domain modeling, what we see when we watched an internal project with sort of hundreds of developers, so close to 1,000. They had what they call a domain model, and when we tried to understand it, there was no chance. And this is the opposite of a domain model. A domain model, as written also in the guiding principles always, is meant to be clear, concise, and comprehensible to everybody. If you created a domain model that is not comprehensible and concise, then you did a mistake. Because keep in mind, who is the audience of that? All the developers you don't even know today. It's not only you, right? And the guys who want to extend later on, the customer extenders, they need to understand your model. And usually that is forgotten. Now, what we see as bad practices, it's hard maybe to show, but let's give it a try. No, because we should not disclose internal models. Yeah, maybe then I just tell you, sorry. So your domain models should look like a tiny little bookshop, or maybe the bit more not that tiny S-Flight model. It's actually, we have seen smaller models, but just polluted. So how could you pollute it? For example, you could start in adding these field control fields. So the field control for distance is this thing. And it's a Boolean, say, or it's an integer with the field control numbers. And it's virtual. There you did several mistakes. Your domain model got polluted by things which should not be there. And you have to fill these virtual fields in custom coding in an after-read handler, which is bad for performance. If you need this kind of things, leverage the option to always add something outside of the definition. So this is the owner of this flight definition. He cared for keeping it very clean. And if you want to add something like this mandatory annotation, you could always do that in a separate file, referring to the original definition and extending them using the annotate syntax or using the extend syntax. And what you can do with that is something like my flights. I want to have these ugly fields in there, which I only need for Fiori field control. Something like that. The rest goes away. And it could even be virtual. So just keep it out of sight. It's too much Copilot help here. If AI is more intelligent than humans, then we have a problem. Okay, so that's it. You find more information on that angle in this guide here, the best practices, aspects, where we talk about aspect-oriented modeling. And the key information that you get is don't think Java. In Java, if you have something like an object base class, then in order to add a property to this base class of all your object, you need to talk to the owner of this class definition. In CAP, that is not true. If you get something from us, for example, a type, a reuse type in CAP Core Common, you can just extend it because everybody can extend everything from everywhere. That's about aspect-oriented modeling. Now, the stateless services, it's really, our services are stateless. Don't keep cache state because we reuse them across all tenants. So if you put something in a cache instance variable of a service, then your tenant A might see the data of your tenant B, which is a bad idea. And by stateless, it means they are scalable, because if they are not stateless, then the next request needs to reach the same service instance on the same cluster node, which is bad scalability. So that's about the statelessness. Ubiquitous events is everything is an event, and everybody can handle an event, fast forwarding to the querying. We said the pushdown is key. So you capture what should be displayed on the UI in very complex queries. We translate it to the database. You are not concerned to it, and get the right data. And this brings us to this passive data thing where I wanted to get to in the fast forward mode, because this is in conflict with guidance, best practice guidance you read from authors. If you read Martin Fowler talking about anemic objects, he's referring as a bad practice to what I refer here as a good practice: passive data objects. So this is the opposite of data transfer object and data access objects, of objects that have behavior. Data in CAP doesn't have behavior. That is very important. And it's very important for you to not try to turn it around. Now, agnostic by design. This is a very important thing. You might have seen that and heard it in the keynote. What it means is whenever you have a service defined and consume, you consume it as if it were local. And in CAP, we implement this hexagonal architecture principle where you have your actual application logic in these inner hexagons, and then the adapters, which you don't see as an application developers. And this is also true in CAP. So means in CAP we implemented a hexagonal architecture solution for you. You get it out of the box. Now a bad practice is when you read papers about how to do hexagonal architecture with Spring, for example, and try to apply this to CAP, then you doubled to hexagonal architecture, which brings unreasonable behavior. And we saw this really in the applications. So don't try to reapply hexagonal architecture, because we already did this. Now, think of the service that I did in the REPL, in the keynote, when I connected to the remote service and used it as if it were local. So it was really agnostic to the protocol. You didn't recognize that I was sending a data request, did you? Because it's agnostic to the protocol. And this is key for local development, because we have this, we can run all our remote stuff locally, because we didn't code against the VIA protocol. Now, a bad practice is you do exactly that. For example, we had one project that used to use Cloud SDK. So Cloud SDK is not a bad thing, but it will always send a data request to a remote service. Means you can't mock it, because it wants to send a remote request. So CAP allows you to send requests to other service conceptually. You just say, do that, and it will do it wherever it is, local or remote, via our data or not. So this is key for local development. And the other one is the last core feature is intrinsic extensibility. Everybody can extend models, as we saw in the aspect-oriented modeling. Nick and Vitaly and Vladimir show how business logic is possible. And the last thing is the framework itself is extensible. And this is something that people seem to miss as well sometimes. So whenever we, as CAP, don't support out of the box that you would like to have out of the box, think about, hey, you could add it out of the box. Because what you can do is, you can also register generic event handler, as we do. The CAP framework is just a bunch of generic handlers registered to something like, hey, for all database services, I want read operation, and for all entities, I want to add this additional code. And this is what you can do as well. Or you can do something like, you know, as I did it here. Let's say I started with a bookshop application. I have the catalog service. So the catalog service has an implementation, which is a bunch of event handlers. By the way, we can see that here. I can also make it bigger. This is the implementation of the catalog service. A bunch of event handlers, usually or quite frequently, generically registered. So before everything, or before read any, this is how to read it. Now, and I can execute a query on the catalog service. We had this cats, whatever. And now I do it with a real catalog service. So it works. Now everybody can add everything to every CDS definition, and same with each service instance. I can just add another handler like a before any, so any operation on any object, and I do something like with the rec. So doing the same query again, and we see there is our additional handler is active. So it's really that thing, CAP by design, everything that you get from the framework, our core types are extensible, our core services, even the database services. By the way, I can really do that as well. A database in CAP is just another CAP service. So I had a similar handler to the database service. Now let's do that one again. Now I see a lot of additional booths, right? You see the database service does a begin, read, commit. Yeah. Okay, so this is an extensibility thing. And make use of it. And this is how we develop our framework. So start with generic handlers in your code base. Then you could externalize it into a plugin to share it with others, or convince us to do it generically. Best practices, section 2. Local development. Local development makes you very fast. That's one thing. Turnaround times, because you don't always wait for deployment. So use CDS Watch, use REPL, and the Maven Java equivalents. It also gives you one more thing. If you think about CAP-level data federation, I introduced it this morning how to describe data products as a service interface, consume it somewhere else by adding a consumption view, and then consume it as if it were local. Now, if you have local development, then you can just start this thing and get the other service, the source of that thing, mocked automatically by CAP, which allows your team, your consumption team, to go on and spawn another team in parallel that cares about whatever should be behind the scenes. You don't have to wait for them. And we saw this in a project. They had exactly that situation. But they didn't get this point of they could just go ahead and do the local development, because they didn't do local development. So they waited for the other team doing the behind the scenes job bottom-up way. And guess what? They waited for 6 months, and then they lost trust in this bottom-up team, and they did a workaround. And they never returned from that workaround. 2 years down the road, they were spent. So what they should have done is adopt local development, do the CAP-level data federation, and just get your application done. And in that year that you focus on your application work, the other team focuses on the behind-the-scene thing in parallel. What is the best way to speed up development? Parallelization. So this is what they completely missed. And this is what I wanted to stress. Fast and local development is not just about this fast turnaround times. It's also about these options of parallelizing your workloads across a larger team. Yeah, CAP-level service integration, which is where the term Khaleesi comes from, is the same. It's just a CAP service, you describe it, so whatever you want to consume from wherever, try to describe it as a CAP service and consume it as a CAP service, because then you have a home run in local development, speed up things, etc. And this all ends up in you should focus on your domain. Yeah, and as said, this agnostic hexagonal model is key for this local development. So all these things are interwoven. Now, AI-based guidance to best practices, this is the best thing AI can do in our world, I would say. Yeah.
Sitting nervously on his
Yeah.
chair already. We're at the end of the session, but I don't want to let you go with final words. So please summarize what you wanted to say, and then we'll continue.
Definitely. Volker already informed me, but I ignored him, as usual. So just the final words is, this list is like the inverse, except for a few things which I wanted to stress, but reach out to us. The OData $badge. HTTP is pretty good in sending parallel requests. Try to use that instead of wrapping it into a badge for us to unwrap it and serve it as if you would have sent us parallel requests, right? So $badge, sorry about this, but it's one of the worst things of OData.
So Daniel, thank you very much for your presentation. Thank you much for your passion. Anybody can tell how passionate you are about the topic. And yeah, we'll close up with our next session, which starts in 3 minutes. So DJ, please hurry. And thank you everybody for your attention.